Today we are going to discuss about Got cookies, cookie-based authentication vulnerabilities. Often we see cookies a lot of times, not only just the cookies jars, but in the web application and a lot of time in security, especially because token-based authentication are not yet that much popular, right? So just a quick introduction as already given. So I'm just skipping this particular part. Agenda for today is going to be introduction to cookies, what they are for those who don't know the current scenario for this particular talk. Then we are going to talk about vulnerabilities in cookie-based authentication, some real-life case studies around them, and a quick wrap-up around that. So this is a little cookie monster, and we all know that we see such kind of cookies in our jar. But in web application, cookies are a lot more different. We use cookie for a lot of purposes, from authentication to tracking to just providing some information to third-party websites or something like that. So assume that what if there is no state in an application? Any user can see any data flowing, right? That would be a big mess. So cookies were initially introduced to implement some authentication mechanism and introduce like what user has what kind of access, right? Or what kind of information should be provided to what user. So initially the authentication were application were using highly cookies. These days there are tokens and some other stuff, but cookies are still widely used by a lot of application. So today we are going to solely discuss about vulnerabilities in cookie based authentication, and this is a quick mind map. I'll be quickly switching over my screen to a different one to take you through a totally new world of a mind map, and we'll be presenting through that. Just a second. Okay, perfect. Okay, so again, there are a lot of vulnerabilities which you can identify in cookie-based authentication, starting from cross-site scripting. Now, a common question a lot of people ask is how we can identify, exploit cross-site scripting in cookies, right? So this is a simple solution. Assume that the value of cookie parameter, let's say name, is reflected somewhere in the application. Now you try to change the value of this name parameter to access payload, and it may result into a cross-site scripting. Now, this is more of a self-accesses, but you have to find a way to execute or inject cookies, arbitrarily. Like, for example, using CRLF injection, you can try to add a cookie named name and with having a access payload, and this may convert a self-access into good accesses. So today's talk is not just only about how you can exploit and report vulnerabilities in bug bounty, but it is more about how you approach a pen test, right? Now, moving forward, there is another issue which is insufficient session management. So, as I initially discussed, that cookies are heavily used for the session management and defining what user has what kind of access, or even if they have some access or not, right? So, in a lot of scenarios, that session doesn't expire on a manual logout as well. Now, this thing can be only on the server side. So what does it means by only on server side is when you manually log out from an application, it logs out from the UI, but the session token or the session cookie doesn't expire at all. Okay, and you can reuse this session cookie to perform the actions as an authenticated user. Second thing is both server side and client side. So as already discussed in the server side, now talking about client side, what happens is when you refresh the user interface, or when after some time you come back to the user interface, you will find that okay, user is already logged in even after you perform the logout action. Okay. Now, moving forward, the session doesn't expire on password reset or change, or the session might be having a long expiry. These might be some of the other interesting issues related to session management when you use cookie-based authentication. Now, concurrent session is a very conflicting term over here. A lot of people say that concurrent session is a not a security vulnerability, but it's more of a best practice, or you can say it's a feature, because a lot of application wants you to have multiple parallel session on multiple browsers, or you can say multiple different IP addresses. This is true, totally true. But in some situation, the application also should have provide some options like a tracking system where you can see all your sessions, or an option where you can log out from all the sessions. So if the application is not having such kind of option, concurrent session might be a vulnerability as a best practice. Now, moving forward, session fixation is another interesting term where attacker tricks the victim user to use a session identifier which is known to the attacker. Now, what is the goal of this particular attack is to fix a session to the attacker, and once attacker is logged into the user is logged into the attacker control session, there might be some malicious payloads triggering or something like that, which can again help an attacker to perform sensitive action from the victim side. Moving forward, the privilege escalation can be one of the another interesting aspect of the cookie-based authentications. There are multiple type of privilege escalation like vertical, horizontal. Let's talk about horizontal one first. Assume that the application uses a multi-organization model, right? Now, cookies are used to define which organization a user can access. Now, after the cookies, alter the cookies in order to access some other organization. Let's say there's an organization ID called 1234. What if I can change the cookie having this organization ID to 3456 and try to access some other organizations, right? Now, moving forward to the vertical proof escalation, similarly, let's say the role is determined by the cookies. There's a cookie called role, and now the role says admin. What if I change it to super admin and try to see if I can access the super admin user? This can help me to elevate the role of the user. This has been seen a lot in the previous, especially in the old application, PHP-based application, where there are a lot of cookies and application utilize cookies for complete authentication as well as authorization metrics. Okay. Moving forward, IDOTs can also be found in cookies. There are a lot of scenarios where you can simply tamper with the various IDs, just like we discussed in the previous escalation scenario. That let's say there is a user ID going on, say user underscore ID is a cookie parameter, and let's say there's a cookie in user ID is 1234, and now you try to change it to 2234 and see if you can access that particular user's data, right? Now, syncs cookie security attributes. This is more of a security best practice where you check for the various security flags missing, like HTTP only flag, which protects if cookies cannot be stolen over the JavaScript or XSS payloads. Missing secure flag, which helps you to, basically helps cookies to prevent them by being hijacked or exploited over the HTTP protocols. So same site flag basically helps you to prevent from cross-site request forgery attacks. Now, moving forward, there are some guessable and weak cookies as well. So check if the cookies are not generated randomly by issuing multiple cookies, and you can use burp sequencer to analyze all those cookies collectively and see if there is some kind of entropy or some kind of randomness. And a lot of times you will see that some applications are just using MD5 hashed cookies or just using base64 encoding for the cookies and something like that. The scenarios are very rare in this particular case, but you can always try your luck over that. Check if some known or weak cryptography is used, as I already mentioned that they might use base64 encoding, which can be easily decoded or forced. Moving forward, session puzzling is more about when an application utilizes the same session variable for the multiple purposes. Now, assume that when you perform a forget password action, the application assigns you a session token, right? Once the session token is assigned, you can also try to use the same session token for performing an authenticated action. Now, in this case, an attacker can easily try to perform a forget password request for an victim user by just typing his email and get the session token. These scenarios are very less seen in the real life applications, but you can always try your luck again. File inclusion. Now, this is a pretty interesting attack. You can also use the cookies to perform local file inclusion kind of attacks. Let's say if your cookie is using some kind of server side values, let's say some particular file, let's say welcome.php or something like that, to display a welcome banner. Now you can try to alter that particular file's name and try to see if you can basically perform a local file inclusion attack. So let's say there's a welcome cookie called welcome equals to welcome equals to welcome.php. Now you can try to say dot slash etc password and try to see if you can read the local user's file of etc password. Padding Oracle attack is more of like a cryptographic attack. There is a complete guide given over here. So this is a very more of a cryptographic attack. So I'll leave it to reading that particular guide for you. Similarly, the CBC MAC or ECB encryption is also one of the important things which you can check in the cookies and try to see if the cookies are using these kind of encryption, which can be altered and which can be decrypted as well. So moving forward to the authentication bypass, in this scenario, the cookies are not properly validated. So what happens is you are trying to access a protected resource, let's say profile.php or let's say some payments.php page by removing the cookies or directly hitting that particular endpoint. And if you are able to access for that particular user, it means that the application is not validating the presence of cookies at all. Now, parameter pollution is more about like assume that cookie utilize a parameter called user ID to retrieve some sort of data for a specific user. Now, You tried for the IDOL, which we discussed earlier, but it was not helping you out, right? Now, what you can do next is add an additional user ID parameter and add a value with the victim user's ID. For example, as shown here, that user ID equals to attacker and user ID equals to victim. Now, three things can happen here is the application may retrieve data of the victim user, the application may retrieve data of both attacker and victim user, and the application is not vulnerable and doesn't return anything out of the attacker user scope. Now, SQL injection can be one of the again interesting aspect when it comes to cookie-based authentication. If the cookies are somewhere used in the server side or performing some kind of server-side reading and kind of interaction with the database, you can also try to inject some sort of SQL queries and try to see if you can get something interesting out of that. Okay, denial of service or cookie bombing. So what happens is there are a different kind of server which accepts only a specific length of cookies. In this particular attack, what an attacker tries to do is to force the server to process the cookies larger than the restricted cookie size defined by the server, which may cause a denial of service attack. There is a nice blog given over here. I'll share the link to this particular mind map as well, so you can read. There is also a blog on the same, which you can also go and refer about this. Talking about mass assignment, which is pretty much similar to the parameter collision attack, where an attacker try to inject multiple user IDs and same user ID parameter. So in the parameter pollution, what we saw is that we are using multiple user ID and values. Let's say user ID equals to attacker and user ID equals to victim. In mass assignment, we are trying to use user ID equals to victim and attacker, or user ID equals to attacker and victim, like that. Now, arbitrary cookie injection is something like an attacker is trying to inject an arbitrary cookie in order to perform some interesting action. This can be achieved using CRLF injection. Okay, and sometimes it can be used to escalate privileges or perform cross-site scripting, as we discussed in the very first thing. That if the cookie is vulnerable to cross-site scripting, you can try to inject that particular cookie using the CRLF injection. Okay. Insecure deserialization. Let's say the application is using PHP, which is also using the serialized objects in the cookie parameter, right? Now, you can easily identify those serialized parameter by looking at the cookies, and if the source code is available, that's a very great thing, right? Now, if the cookies are using serialized objects, try performing insecure deserialization check. In PHP, it's called PHP object injection attack, and this is pretty simple to exploit and can get you the remote code execution as well. Cookie length violation is similar to the cookie mass bombing attack. It may cause attacks such as buffer overflows in the application. Now, what we are trying to do in this cookie length violation attack is we are providing a cookie more than its assumed length. Let's say the application is accepting only 1024 length of the cookie, but we are providing, let's say, 10,000 length of the cookie, and try to see if we can perform any kind of denial of service or kind of overflow the buffer for the cookie. Session donation is again a conflicting attack where this particular block says that you donate your session to the victim user, which is again less probable. You have to rely upon some attacks like CRLF attack, CRLF injection, or something like that in order to use your session token and donate it to the victim user. Now, this attack is more helpful when the application is having some sort of self-stored cross-site scripting, and you want to convert them into good stored cross-site scripting, where you can try to trick a victim to use attacker session, and then further, once the victim is logged into attacker session, the cross-site scripting payload will execute and perform sensitive action on victim system or something like that. Sensitive data stored in the cookies. So a lot of time, some PII information such as email address, mobile number, some date of birth, or something like that could be stored in the personally, like in the cookies. Now, these PII information or other sensitive information should not be stored in the cookies, especially in a plain or easily decodable or decryptable form, right? Uh, Especially when it comes to the healthcare or some similar industries where the sensitive data is the utmost priority and the concern, the application has to make sure that such kind of data should not be stored in the cookies. Now, as I already mentioned, that this information usually includes email, date of birth, mobile address, SSN, etc. Okay, so this more of concludes my talk on the cookie-based authentication.